Hello, in this video, we're going to be talking about some of the initial ideas of calculus. And these are kind of the two ideas of calculus. One that will come much later is about how do we find the area under a weird curve, which is like hard to do. So we want to try to find some method of finding this area under a curve. What we're mostly going to be talking about in this video of is if we've got this goofy curve, can we find the slope of a curve? We have found slopes of straight lines for years. You might recognize this. That's the slope of a perfectly straight line. We're going to be calling that the average rate of change. It's just slope, but average rate of change, all that is slope. Now, we've also got this little notation. Sometimes it's used, sometimes it's not, but it's just for a small change of x. If x changes by a little bit. So we can rework our old slope formula and say, okay, well, our x value started at something, c, and then it got a little bit bigger. And so it got a little bit bigger. And then we put that c value into our function. And then we've got put that little bit bigger version of c into our function as well. So y1, y2, x2, x1. The question of calculus asks, what happens when this value gets really, really small? Like not actually zero, but it gets really, really small. Well, then if it actually was zero, we get c minus c, and we'd be dividing by zero, which is a big no-no. So what could happen if we get a really, really small value of c? Why is that important? Let's look. We've got an object that's dropped from rest at the top of a tall building, and it falls at this like curved rate because as it falls, it picks up more and more speed. If we wanted to find the average speed, that's easy. You just figure out, okay, well, it started at 0, 0. After 3 seconds, it's fallen 144 feet. I did that by plugging in 3 into this function. And you find the slope between those 2 points, and then its speed is 48. I mean, its average speed over those 3 seconds is 48 feet per second. On average. There were times where it was faster than that and times where it was slower than that. But on average, over those 3 seconds, its speed was 48 feet per second. But a more interesting question might be is like, well, what is its speed at 3 seconds? Oh, well, if you try to apply your slope formula, you try to find the slope between a point and itself, and you end up with 0/0, and it doesn't quite work out. So the idea is, what if we did just really, really close to that? Before we were doing like a 3 second gap. What if we did like a 2 second gap between those two? Then we're able to figure out what closer an estimate of what the speed would be at 96 at 3 seconds. It's about 96 feet per second. I have a cool kind of like demonstration of this over here. So this is that same function. This is a cool like Desmos tool. The idea is here's our average rate of change. We can see like overall that after about 1 second, we're getting about that 48 that we are getting. After 2 seconds, we've got about 96, 3 seconds, whatever. But what we're trying to do is we want to figure out, okay, well, when our time is 3 seconds, oh, I'm going to get to 3. I want to know what is the slope of that line. But I want that slope of that line to be when I bring these 2 points, because I can find the slope between 2 points, but that's not quite following the curve. I want to get these 2 points really, 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 really close together until they become that same point. What happens when we smush our two slope points together to become a single point? We can never actually get them all the way there, but where is it heading towards so that we can get an idea of what the slope of this red line would be? That's one of our first goals of calculus. So, our first thing that we're going to be looking at is what happens when we put two things almost to a certain point, but not quite there. wrapping up this short video, um, again, area is going to come much later, but mostly what we're trying to think about is how can we find the slope of a curve? How can we find an instantaneous rate of change rather than an average rate of change? Our old slope formula, how can we figure out what is changing at a single instant rather than two separate points? This was the kind of hand wavy video, but thank you for watching. Goodbye.